So hello everyone, in this video we are going to see a solution of a problem of question number 2. Let us read the problem correctly. A cold storage room has a wall made up of 0.23 meter thick layer of a brick. So let's draw a wall made up of a brick which is having a thickness of 0.23 meter and having a K value equal to 0.98. So K for brick, it is 0.98 watt per meter Kelvin. On the outside, adjacent to it, 0.8 meter thick layer of plastic foam. So we will consider this to be as the inside of the brick, this to be as the outside of the brick. So at the outside you are going to have 0.08 meter of plastic foam, okay, which is having a K value equal to 0.2, okay, for Kp equal to 0.2, which has been given. Finally, 1.5 centimeter thick layer of wood on the inside. So they are speaking of brick inside and outside. So you have inside, you are going to have a thick layer of a brick, thick layer of a wood, K wood equal to 0.17. The thickness of it has been given as 0.015 meter, that is 1.5 centimeter. So you have the arrangement of a wall in this way: wood, brick and plastic. Further, the outside and inside convection heat transfer coefficient and temperature are given. Okay? So outside, we will consider this to be as a outside and this to be as a inside. So outside HO, it has been given as 12 watt per meter square Kelvin, and temperature of outside they have given 22 degrees centigrade. HI they have given inside 29 watt per meter square Kelvin, and TI they have given -2 degrees centigrade. Okay? So from this figure, how much resistance are been there? The resistance, first of all, due to HI, then due to KW, then due to KB, then due to KP, and then due to HO. So there are total 5 resistance. 2 resistance are due to the convection and 3 resistance are due to the conduction. Now let us assume the direction of a heat flow. Now let assume the direction of a heat flow to be this, from -2 degrees centigrade to 22 degrees centigrade. We are assuming direction of heat flow. We are assuming this direction of a heat flow. Okay? Now we know that it is not possible for a heat to move from -2 degrees centigrade to 22 degrees centigrade, but still we are assuming the direction. Okay? Its consequences has been seen in the answer. Okay? Let us draw the resistance diagram for this. So all resistance will be are in series across a temperature of -2 degrees centigrade and 22 degrees centigrade. Let R1, R2, R3, R4 and R5 be the resistance. Okay? It is due to HI, it is due to KW, it is due to KB, it is due to KP, and it is due to HO. Okay? Now let us find out the individual resistance. What will be R1? It will be 1 upon HIA. Now in the given problem, they have asked you to determine the rate of a heat removal by refrigeration if the total area is 90 meter square. So area, it has been given, it is to be 90 meter square. So you know the value of HI, you know the value of area. So you just need to put the values of area and HI. You will get this answer. Kelvin per watt. It will be the unit of resistance. Similarly, R2. Here R2 resistance is due to the conduction. So you have R2 will be equal to 0.015, that is the thickness, divided by kW, it is 0.17 into area, that is 90. So you are going to have the answer to be as 0.0009803 Kelvin per watt. Similar way R3, so it will be 0.23 upon 0.98 into 90. Here the answer will be 0.0044. So you need to first of all calculate the respective resistance. So R4 all this are been found out by the formula B upon Ka. The resistance for conduction equal to B upon Ka. Now B and K are variables. Okay, for slab, wood, brick and plastic. R5 again it is due to the convection, so it is 1 upon HOA. So it will become 1 upon HOA is 12 into 90. So it will have its answer as 0.000925 Kelvin per watt. Okay? Therefore, total resistance will be equal to R1 plus R2 plus R3 plus R4 plus R5, and which will, you need to add this total resistance. You are going to get 0.009296 Kelvin per watt as your total resistance. So your Q will become delta T upon total resistance, which will be equal to delta T is -2 minus 22 divided by total resistance 0.009296. So you will have your answer as minus 2580.85 watt. Now this negative sign indicates that assumed heat flow direction is wrong. What we have assumed initially, we have assumed that the heat is going to flow from -2 to 22 direction, -2 degree centigrade to 22 degree centigrade, which is wrong. That's why you are getting negative sign. But the magnitude, whether the magnitude is going to change? No, the magnitude is not going to change. It is going to remain as it is. That is 2580.85. Now further, they have asked you to find out the temperature of inner and outer surface of the wall. Okay? So they have asked you to find out this temperature T1 and this temperature T2. Let us assume that T1 be the inner surface temperature of the wall and T2 be the outer surface temperature of a wall. So in a figure you can mention T1 as over here and T2 as over here, as this is your Ti and this is your To. So here you need to use a formula Q equal to Ti minus T1 divided by how many resistance are in between Ti and T1? There are total only one resistance, so you have R1, which will be equal to T2 minus To, T2 minus To divided by how many resistance? Only one resistance, that is R5. So from this you can easily find out the value of Ti because Q is known to you, T1 is known to you, and R1 is also known to you. So from this you calculate Ti, you will be getting Ti equal to minus 1.011 degree centigrade and TO equal to 19.611 degree centigrade. While considering the value of Q, you need to take the value of Q as it is with its negative sign. Okay, in this formula. Okay, so that Ti will become minus 1.011 degree centigrade and TO will have the value of 19.611 degree centigrade. So this is the actual solution of question number 2. Okay.